Hello, this video is a reveal of Brae Head as a zone highlighting reactivated faults in Jamaica. This video outline is done in reverse to help with the telling of my story. Now, Brae Head is located in Clarendon, Jamaica, within the Rio Minno Crawl River Fault zone. As per sources, Rio Minno Crawl River Fault zone is primarily in an east to west trending fault. With this being said, the reactivated faults are said to be north-northwest striking. Within this area, especially with the terrain maps as support, I have now seen where both of these faults intersect, and this Brae Head Falls is the perfect highlight of same. Now this screenshot is the highest point of the Brae Head Falls. As we can see in this image, look at the imbrication of those boulders. This is what grabbed my attention first. From there, you can see that the boulders display a paleocurrent where it actually is from east to west in terms of how the photo is oriented. With this being said, the falls is flowing from west to east based on the nature of the photo. I also notice this gap underneath the big rock strata. How is this possible? Look also at those angled breaks in the rock. How is that also possible? What is the cause? Could it be fault movement? Now, for reference, this location is approximately here. This zone is after the clip I just showed you. Notice we're not really seeing that many boulders right here. The gradient is relatively flat. Why aren't we seeing as many boulders as we would have seen just a while ago on a previous clip? This section, we can now see another part of the waterfalls. This section of the waterfalls is even much more steeper. Look at the many boulders that are right here. This is a representation of that reverse faulting as how I interpret it. Now run your eyes at this location. So see the boulders, and within meters, there are no boulders. None whatsoever, relatively flat land. This I interpret as the strike slip fault location. Notice now how I buck up again on boulders here on the flanks as I was moving away from that flatland location. And then here is where there are other boulders as well. This map is for reference in terms of where the flatland and the location of boulders are. In essence, the flatland is where the strike slip movement occurs, and the boulders is where the reverse faulting of the reactivated fault occurs. The terrain map here highlights, especially based on the nature of the topography, that both of these faults are active. If we're going to have, as we see here, those contours highlighting areas of steepness and relative areas of gentle slope, we definitely can see from this that there is active movement from both of these faults taking place. And this area is the perfect reveal of this homogeneous interaction between the strike slip and reverse faulting. This lake, this depression, is as a result of the higher reverse fault zones immediately surrounding that strike slip area. The clay silt soil is perfect for this lake development. This is a beautiful phenomenon.